Hey, it's Mr. Allred, and we've been doing some exponential functions, and I'll remind you that those look like f of x equals a times b to the x, where a is the starting amount, and b is the multiplier, which is similar to a rate, but it's more like a ratio in this case. So I've got some tables here, and I want to write some exponential functions if they increase exponentially. Well, the first thing to do is to notice that on the first line, when x is 0, the output is 4. So if I come back down here to this starting amount, that would be an a of 4. Now what I also need to do is kind of see what's happening. So it's important to see that the x is growing by 1 each time. So growing by 1, growing by 1, growing by 1. But as x grows by 1, what happens to the output? Well, I added 4 here, but then I added 8, and then I added 16. Well, instead of saying I added different amounts, let's see if there's a common ratio between them. So another way to get from 4 to 8 is to double it. And then I can double 8 to get to 16, and I can double 16 to get to 32. So in this case, the multiplier, it is doubling times 2, times 2, times 2. The multiplier is 2. So the way we could write this function would be f of x equals, it starts at 4, so it'll be 4 times 2 to the x. And we can plug any of these x values in and see that we get the f of x value over on the right. Okay. Now, the second one I have here is a table, and the first part here, when x is 0, the output is 80, so that gives me b as the starting amount being 80. But what's happening here? I go from 80 to 40, go from 40 to 20, and I go from 20 to 10. Now, it might be easy to notice that we are cutting this in half, so we could say we're dividing by 2 or multiplying by 1/2. And that is the multiplier. Ooh, I got these backwards. The a is 80. I'm getting my functions mixed up. A is 80. The b here is 1/2. So we can write the function as f of x equals 80 times 1/2 to the x. But very quickly, let me show you another way to get this b if you do not recognize what's going on. You can take one output and divide it by the previous one. So 40 divided by 80 would be 1/2, or 10, the last one here, divided by the previous one, 20, would be 1/2 as well. And if you look back at the previous example, 8 divided by 4 would be 2, 32 divided by 16 would be 2. So we can find that rate by dividing two pieces here. So let's say here, this is the 40 and the 80, and then let this one be, these two. Alright, so let's see if we can do that with something else. Oh, here's a graph. Let's see what we can get out of the graph. So we're going to write a function for the graph. So let's see here. The two things we need are the starting amount. So when x is 0, way up here, the starting amount, so f of x equals a times b to the x, the starting amount is 16. Now let's see if we can get the rate. So it goes from 16 to 4. Now let's use what I just told you. We can take one output, which is 4, and divide by the previous output, which would be 16. And that gives me 1/4. We'll have another point on here marked, and it is 2, 1. So let's try it. Let's take the output of 1 and divide it by the previous output of 4, which is 1/4. So the b value here, the multiplier, is 1/4. So the function would be f of x equals 16 times 1/4. 4th to the x. And you can plug in 0 for x in your calculator and see you get 16. You can plug in 1 for x in your calculator and notice you get 4, and so on. All right. Let's do 2 more examples. They're not as friendly as the other ones, but let's see what we get here. We're going to write functions from descriptions. Freddie's credit score is 450. He gets a better job and is able to pay his bills more effectively, and he notices his score increases at a rate of 3% per month. Write a function to calculate his credit score and find his credit score after 12 months at his new job. So let's see here. What can we write this as? We could call this his credit score after so many months, so C of M. Well, some things are not too hard. If we think of the generic version here, f of x equals a times b to the x. The a is the starting amount, that is 450. The b here is adding 3%. So it's an increase of 3%. Now, you have to know a little bit about percents, but let's just see if we can make this logical. So his starting amount is 450, and we know we're going to raise something to the m. Well, we don't want to use 3 because that would triple it, and we know that tripling something is not 3% of it. But we can't use 0.3, so we know 3% equals 0.03. I'm sorry, we can't use 0.03 because that would make something small. Okay, that would be just a portion of something. So how we get there is we want the 3% plus his original credit score, which is plus 100%, which is plus 1 basically. So we're going to multiply by 1.03, and that's basically the same thing as 103%. So you can look at it as 1 plus 0.03, or we can clean that up to 450 times 1.03m. So what that does is it keeps the original 450, because of the 1 here will just be a multiplier, and the 0.03 is what tacks on the 3%. So let's see, if that's our C of M, let's just try it out. Let's try his 12 months. So we're going to try C of 12. Now we have to verify that we're putting this in the calculator right. So let's see, 450 times 1.03 to the 12th. So I'm going to do it, and I want you to do it as well to make sure you get the same thing. And if you have no idea, you'll see here in a second. So we know we should get something more than 450, right? I get that his credit score has gone up to basically 642. Okay. So let me just kind of throw this out there. If we did just 0.03 raised to the 12th and then multiply that by 450, 0.03 raised to the 12 times 450, I get an extremely small number. My calculator won't even display it. Okay, and if I do 3 raised to the 12 and multiply it by 450, I get basically 24 million. So his credit score went up way too much if we did it that way. So just kind of keep in mind. But if you've got percents, realize you want to write them as a decimal. And this one, it was increasing by a certain percent. So what we did was we kept the original amount, which was 1 or 100%, and we tacked on the extra 3%. So let's see the next example on how this will vary. A kid's pool contains 30 gallons of water. During the summer, 5% of the water evaporates each day. Write the linear function and calculate the number of gallons left after 7 days. So let's see what's happening here. Once again, we're writing a linear function. We know that the starting amount is 30 gallons. and we're going to have the change is in losing 5%. Okay, so that doesn't mean we're keeping 5% of the water, because then it would go away really quick. We're losing 5%. So let's see here. What could we do? We could call this function W for water after a certain number of days. And we know it starts at 30. And that'll be 30 times something raised to the D. So let's see what we can do with this guy right here. So we know we have the original amount, which is 1 or 100%, and we're losing 5%, which will be losing 0.05. So more or less, when we lose 5%, we keep 95%. So let's see here. If we write this out, 30 times 1 minus 0.05, that would be 0.95. That would be the 95%. So we might be dropping 5% every day, but that means we're keeping 95% of what we had. Okay. So in the previous example, his credit score was going up by 3%. So he had the 1, and then he had plus the percentage. And in this one, we have going down by 5%. So we have the 1, which is the original amount, and here we're losing the 5%. Okay, so kind of keep that in mind. It's changing by that percent, so we may be adding that to a 1, we may be subtracting that from a 1. And let's answer the last question here. How much will be left after 7 days? So we'll say 30 times 0.95 raised to the 7, and let's see what that will be. Calculator. I'm getting roughly 21 gallons left. So more or less we've lost 9 gallons, but we still have 21 gallons left. All right.